have to anybody who can discuss with me. So I request you in this meeting, you ask more and more questions, because with interaction only we can get more into the subject. So wherever you find a little bit problem, even I am not the perfect in Tensor, so I try my best to make a good presentation on this one. So this is the first line when I started studying from the beginning, that tensor analysis is the type of subject that can make even the best of students shudder. So you can think that it's not an easy topic, but I'm trying to make it easy for you. Let us discuss the concept of tensor first. If we get the concept of tensor at once, then I don't think it's the next topic will be tough. Let's start from the quantities. If somebody asks how many, say some stones in your bag, you will say 3 or 5 or 10. It means for that answer we just require a number, 3, 5 or 7. If it is asked what's the temperature now, you will say temperature is 75. No, you have to put some value in it, 75 Celsius or 45 Celsius or Fahrenheit. So this is a quantity which is scalar, which can be described only and only by its magnitude. Next comes vector, which is, I'm just because I started from the beginning, vector. If I say, okay, where do you live? You will say at 3 miles from here. So 3 miles, in which direction? 3 miles, this direction, then you will say 3 miles, you go first 2 blocks on the east, 3 blocks in this side and 2 blocks on the top. So it means there is a direction included in it. In vector, this is a vector which has 2 things, direction as well as magnitude. And direction is divided into 3 components, I, J, K, which I am talking about the 3-dimensional. It may be n-dimensional theoretically, that, but anyway, it has 3 components. It is a vector. And vector can be represented in an array 2, 3, 4, means 2i cap, 3j cap, 4k cap. But there is a limitation on vector, because a vector can give only one direction at a time. Like this is a vector. Okay, this direction and some magnitude. This is a vector, one direction. But what if you need 2 directions at a time? Suppose there is a quantity, I will explain some examples of tensor, where we don't need one direction. At a time we need 2 directions. We need 3 directions. Then which type of entity will become? That entity is tensor. Even vector has the limitations, that suppose if we want to change the vector, if you say, suppose there is a vector A, you say multiply by 5, it becomes 5 times of 8, but it changes the magnitude. But if you have to change the direction, what are the options? You will say, okay, multiply 5A dot B. Do you think we will get a vector? No. This is inner product or scalar product. We will get a scalar quantity. Suppose you will say, okay, A cross B, this is a vector product. But you know, in cross product, we are getting only one direction, which is restricted to perpendicular on of it. But from this A, if you want this direction, can you get? No. A cross B can give only, if this is A and this is B, I will just get this direction or this direction, means perpendicular to A. But if we want to change the direction from A to B, A to C, what is the option? So here comes the existence of a tensor. Now I start the example for tensor, where we will need tensor and which quantities are tensors. Let us start with the basic quantity. You might have heard about this formula, B equals to mu h. B is flux density, H is magnetization. What about mu? Mu is scalar or vector? What is mu? Huh? it looks like scalar. Okay, it's just a mu for space. It's 4 pi 10 to the minus 7, something like that, or 1 over 4 pi 10 to the minus 7 something. I don't remember value as it is. But this is for free space. But when there are some materials, when the whatever material is this, if this is not isotropic, then there will be a problem that B is in different direction and H is in different direction. There are two types of materials. Isotropic. Isotropic means same, like free space. But there are anisotropic materials in which B and H are not in same direction. Then what about mu? What will you say about mu? It means mu will have two directions at a time. How? Say mu has two directions. How it will be done, I will tell you later on. But it has to satisfy this equation. And to satisfy this equation, it should be something like that. Say mu is vector u, vector v, which is a tensor, dot h. Now what will happen? V with h give you a scalar number, and the direction of u will be the direction of b. Where mu is, I assume mu equals to a tensor. Tensor is here. This is mu, u, v. It's not dot, it's not cross, it's a tensor product. Okay? If I kept mu here, in place of mu I am putting vu, uv, dot h. So what is v dot h? This becomes a scalar. And the direction of b becomes the direction of u. So what I want to say that in these materials, mu is having two directions, so it's not a vector, it's a tensor quantity. Do you get some point? Are you understanding or any question?
You just give an example.
Yeah, I just gave an example.
So
mu is a tensor.
physical meaning about the mu? Or is there any physical
I
meaning about the mu?
just assume mu equals to uv, and I'm going to explain how tensor is represented in two directions. So if you will ask why this is so, this is just assumption. Okay? If this should be like this, then it can satisfy this equation. Okay? Similarly, if I talk about what it is called, stress. This is the another quantity. You know, stress is some force over area, or F over dA. This is known as stress. Okay. Now the question is, if I talk about F equals to T dA, normally what you will say about T? It looks like a scalar. But the thing is that in any rod, when some stress is generated, at a time two stresses are generated.